Hi, I'm Paul. We're going to look at a LeetCode question here, three-sum closest. I get an email newsletter from LeetCode every week, and it includes a challenge problem. So this week's is three-sum closest, rated medium. Given an integer array, nums, of length n and an integer target, find three integers in nums such that the sum is closest to target. Return the sum of the three integers. You can assume that each input would have exactly one solution. All right. We'll look at example 1 here. All right. So nums is going to have at least a length of 3, so that's helpful. And then the other things seem to be in a kind of reasonable range. But all right. Here, let's look at this. Topics. 2 pointers and sorting. Okay, that kind of gives away the game there. Yeah, we can do it as a 2-pointer thing. I don't think I've seen something like this before, where you try to find the a sum that's closest to something. But if you sort the array, then it's going to be a pretty standard 2-pointer solution. It's going to be. We're going to have to look at all the triplets, I think. So it's going to be an O of n squared algorithm, but let's look at what color is that? Okay, here we go. So let's look at the nums array. What if we sorted it? We'd have -4, -1, 1, and 2. Okay. Now, 2 pointers. We're going to start here. Okay? We're going to start here. This is, I wish this array was longer so we could sort of see it, but we're going to iterate through the array, starting with element 0. Okay? And then we're going to set 2 pointers. We're going to set one cell in front of the current pointer, and we're going to set, we're going to start with element 0. We're going to set the low pointer to 1. We're going to set the high pointer to the max element. We're going to add all of them up. So what do we get? We get -4, -1, that's -5, plus 2 is -3. All right, so that's the best we got so far, -3. All right. Now, depending on whether that number is greater than the target or less than the target, and in this case it's less than the target, which means we need bigger numbers, we're going to move one of these pointers. In this case, we're going to move the low pointer. All right, we're going to move it to here. Now what do we have? We have -4 plus 1 plus 2 is -1. So that's actually better. It's closer to 2 than -3 is. So we'll get rid of that. The new best number is -1. All right. At that point, we have exhausted the possibilities of index 0. So start over again. We're going to advance that, and we are going to go to index 1. Right? we are going to go to the number next to that index, and we're going to go to the last index. And as it happens, this is our last chance. So what does this come up to? 3 minus 1 is 2. 2 is closer to the target of 1. I think I may have said target of 2 before I was looking at the output, but the target is 1. Now what we get here is 2. 2 is closer to 1 than negative 1 is. So that's it. 2. So that's it. I mean, we'll look at an implementation, but yeah, it's a sort and then a 2-pointer problem. All right, let's take a look at this. First thing we do is sort the array. Next, we need a closest sum variable. Now we're going to initialize it to a really big value. And then length, which is the length of the nums array. All right, iterate through each number in the array, starting with I equals 0, and then set the pointers. Initialize the pointers. One is just after the current number, and one is at the end of the array. All right. While, as long as the left pointer is less than the right pointer, we're going to keep going. We're going to get the current sum. We're going to add the 3 numbers, add up the 3 numbers that we have pointers to. We're going to get the current sum. Now, if the current sum equals the target, actually, we're done. So we can just return the current sum because we can't get any closer than that. If that is not the case, I hate that wraps like that. Can I move it a little bit? Okay, good. If the current sum is closer to the target than the previous sum, then we're going to update closest sum with the current sum. So we take the absolute value, current sum minus target, closest sum minus target. Which one is better? If the current sum is greater than the target, that means we need smaller numbers. So we're going to decrement the right pointer, the high-end pointer. If current sum is less than the target, we need bigger numbers. So we're going to increment the left pointer. At the end of this, we will return the closest sum that we found. So let's try it out. All right. I think I'm going to want to move this over and expand it a little bit. All right, go ahead. I should have moved that. Okay. Whoa. What just happened there? Oh, is that the... Gee, that's funny. 14 milliseconds. It's in the top like 2 or 3%, but it's also like the worst runtime. I don't know what's happening over here. But okay. So that is the 3-sum closest. It's a sort and a 2-pointer problem.